All right, so over here right now first we need to have a collection for streams, right? Can we use streams with something else other than collections? No. All right, we can use it over the collections first thing. Another thing why we will see it also, and arrays dot as list. All right, so 1 2 3 and 4, right? So we have just seen the traversal in the last part. So if I want to traverse but I don't have to, I can simply print over here list and just list. But as I mentioned in the last session also, okay, double quotes I have added. All right, no worries. So this is the output 1 2 3 4 list I got, right? But I want to traverse it, and I want, okay, not no modification right now, I just want to traverse it, not use like in this manner, right? And this is from the to string method of list, right? Array list as list provide a array list, and if we see the array list to string method, then we will see these comma over here and these parent brackets over here, right? So over here this is been written, so it's to string method of the array list arrays class. So that's why we are getting this output if I'm printing list directly. So now I want to traverse it normally. So earlier what we can do, usually in the normal for loop we use this thing, right? 0 I less than, and then okay, list dot size and I plus plus. It's similar to the for loop that we use with normal array. And I'll just do list dot get and the index. So it will going to print the data in next lines, right? 1 2 3 4. I'm audible?
Yeah.
And but I don't want it to print in next line. So what I want is, I'll want it in the single line with comma separated data. So I'm just updating the code. Right, so I'm running it again. Now it will be in a single line, comma separated. All right, so this is used to be earlier things. How it happened, right? We had an array list. Internally we had an array list 1 2 3 and 4. So it started from the 0 index. So 0 index will be here. So I want 0 index, then I incremented the index over here, then my I keeps on moving, right? I started from 0. Okay, I need to put here as well. I started from 0 and I is moving towards the right hand side. Why it's moving to the right hand side? Because I'm using I plus plus. So I will keep on moving. So I want a value at ith position. I is 0, so it will give me 1, and this thing will be this thing will be printed over here. Then I have done I plus plus, that means I value has moved to second position, one index. So at one index I have 2, so here 2 and then comma, then I did I plus plus again, then I moved and reached at the third position. All right, then at third position is second index is value is 2, so 2, oh sorry, third position, second index value is 3, so 3 is here and then comma is here, and then again I plus plus, and that index will be 3 and the value is 4, so 4 is printed over here by this method, and then a comma. So this is how things work, right? It exactly as we do in array. But now the thing is, if I want to traverse all the things, right? If I want to traverse all the things, then why to keep index of I, right? Why to keep this index? If I want to traverse everything from the start to the end, do I really want to have the index? So that's the thing that people who wrote the Java gave it a thought, and then they decided, okay, if I want to traverse everything, and I know that there is a list that I need to traverse, that over here we are traversing the list, right? So if there is a list someone wants to traverse entirely, and they want to move from left to right only, not from the right to left, if in this order someone wants to traverse, then why ask them to hold these data where they are, right? So they came up with for each loop, which was introduced in Java 1.5 version 2009, which says, okay, just provide the list that you want to traverse in the for only, then give a semicolon. All right, in that semicolon give, and then this list compiler knows, right? Because compiler was the one who created this list, right? So he knows that which data type it requires, right? So over here we have the list of integer, right? So I can name it value. Now what will happen? Same list, right? Everything will be same. Entire thing will happen in the same manner. I will just copy paste this thing as well. But instead of I don't have to keep the value of I, because I will directly get the value from here. So value and comma. And let me just write one more thing over here. Sysout traversing using for each loop. Is this code visible?
Yes.
So now instead of having this I and manually maintaining it, right? There is no I, right, over here in this code. But internally Java is going at the top, and what it's doing, it's when is at the starting of this list, it's providing here the value of I at index 1, and over here we are printing it. Then it internally pushing this value and then pushing the value 2 over here. Then we are printing it over here. Okay, I haven't run it. Let me run it first. All right, so okay, one more sysout is required. All right, let me run it again. So now traversing through for each loop, right? This code over here. So and then for the next third time it will again push this thing and put the value over here, right? And then at the last also it will take the value from here and put it here, and we are just consuming it. So if we want to traverse in the entire collection from left to right, so I mean, for the array it's left to right, right? But there are some other collections that don't, or the data structures that don't preserve the insertion order, or they don't have any left and right, right? Because left and right is a thing that we use with the linear data structures. Tree is a non-linear data structure, right? So graph, non-linear data structures. So there are non-linear data structures as well. Matrix. So for the linear data structures we can say left to right, but for others we are just traversing, right? Whatever data comes depending on the algo that we are using to fetch the data. All right, so let's move ahead. So it's, if we want to traverse a thing, for list we can say left to right, but in otherwise whatever data, I mean whatever data the data structure will provide us. A stack will provide other thing, latest entered data. Queue will provide it uh, data which has inserted at the very beginning. Heap will provide, depending on whether it's min or max, it will provide us the minimum data or the maximum data. So it depends entirely on the data structures that we are using, the collection we are using, and what data structure the collection is using. So it depends on that. So for the linear data structure only we are saying left to right. So if I want to move, traverse the collection completely, right, that would be better instead of left to right. If I want to traverse the collection completely, so I don't need to have the index, right? I can just traverse it. So why I should create a variable and then do the thing, right? Entire thing over here and over here, nothing new is being happening, right? It just, I'm writing less lines of code. Also I don't have to manage the indexes, so the chances of writing something wrong, the human error, is reduced, right? I'm audible?
Yeah.
So for loop is cool. Are you guys, I mean, good with the for loop? For each loop, sorry, it's called for each loop. Anyone
Yeah.
having any doubts? All right, cool. So this was introduced in 1.5 version, right? This is the legacy one. Normal for loop is legacy code. This is introduced in 1.5. This was introduced in 1.5 version. 1.5. All right. So and then come the streams, right? Obviously introduced in 8. All right. So traversing using streams. Traversing using streams. All right. So now what happens? We already know that, okay, if I want to traverse something, right? So I will move from left to right, right? Until 1.5 version, it was clear that if I want to traverse the entire collection or entire group of data, then I don't need to have the indexes, right? Why should I maintain the indexes, right? So it does not, I mean, if I want to completely traverse it, then it does not make sense to have the indexes, right? Because I just need the values from the collection. So if in 1.5 version I'm not managing or handling any index, so why to handle in 1.8 version, right? After 4 years, why to make move backward instead of forward? So they have come with a different concept, which is a stream, which says that if you have the collection like the list we have, so we can open the stream. And now the thing is, what is the stream, right? This is an interview question also. I mean, we'll get a, in the lead code, if you go and check, there is an interview question where they say that you are getting a stream of data, especially integers, and with that streams at any particular time, they will say that okay, please let us know which is the minimum value in the in the data that we have passed. So you obviously you will collect it in the collection. So but the thing is, and the minimum and maximum, whenever you will see that it's basically of heap. So if you want to mimic that quotient in your local system, then you have to use the streams as well, right? With a little bit of delay. So with the streams, what happens internally, what it do, when I'm saying the streams, if you go inside it, it will say it will open a stream. Okay, requires, okay, collection. Okay, default implementation collection. Okay, all right, it's not saying it, but all right. All right, cool, no worries, it's not in this documentation of this. But what streams do, it's opens a stream. Even if you go inside it, you will see a stream object, right? And this is e will depend on, it's a type. So the list type will be the stream type. So list type is of integer, so stream will be also of the integers. So it will open a stream. And then what's the mean of streams, right? It's exactly the same like the way in which this is working, for each loop is working. Each object will be provided to you, but what's the difference between then the streams and the for each loop? For each loop is linear and the streams are functional. That is, now we are getting a function, right? We are getting a streams object. Now in the streams object, I have multiple methods visible. So right now I just need to traverse everything, so I can use for each. So for every for every value over here, list will have these values, right? Where these values, the list have these four values. So for every value I will get a stream object. Stream object, what it will do, it will keep on passing the values over here in the for each method. And over here I need something to hold that value, right? So I can write the val. So what will it pass? It will pass 1, right, for the very first time. So the 1 will be stored over here. In the next time it will store the value 2. Similarly the value over here it's keeping, right? So we don't have anything, so we can have the value keyword as well, right? It's not fixed, anything you can use. So right now what's happening, 1 will be provided here, then 2 will be provided here, then 3 will be provided here, and 4 will be provided here, right? So in the similar manner that this thing is working, similar manner this thing is working also. So now one can say, then how can I use this, right? So simply what we want to do with this value, we just put it over here. I just copy pasted this line over here. Okay, I have to paste it again over here. All right, visible? This line I just cut, copy, and I'll just paste here. All right, copy pasted that thing. Declare this variable as value. Same thing. So line number, these thing, for each loop, and this has no difference. And if I run the code, okay, I need to use this out one more. Now if I run the code, traversing using streams, traversing using for loop, and traversing using normal for legacy for loop. So everything is same. If you know the for each loop, then the streams do the same thing, but in the functional manner. You just have to use dot 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 dots. Am I audible?
Yeah.
Now you need to work on it again and again, because in this writing style, because we have already done, see, I have already started the streams with not streams, but with the functional programming with the multi-threading, right? So over there we were doing with working with the lambdas, right? So this is the same thing, right? Same thing we were doing it there also, right? I'm audible?
Yeah. Yeah.
So this is lambda functional, Java functional programming, and coding annotations are there, right? You can go through it and read about it, and you will see a lot of these things, right? We can say just normal, and you understand this concept, right? What happened over here? How this thing worked? Anyone having any doubt, please let me know now. Hello, I'm audible.
Yeah.
We can move ahead, right?
Yes. Yeah.
All right, cool. So, all right, just give me 1 minute. So now we know that we can, now we know the ways in which we can traverse a list or a collection, right? It's not like with the, we are working with a list, we'll move to different collections as well. Now there are two things that we have already mentioned in the notes as well. Okay, let's move one by one. Let's cover first. Okay, let's do a different thing. Okay, but okay, whether we should dive deep into this or we should do the collections sorting. Okay, let's dive deep into this with the traversing part and what issues we face while traversing. All right, all right. Now this would be an important interview question. So we know how to traverse a collection, right? We know how to traverse a collection, right? And how many ways we can traverse a collection? 4 ways. Okay, not here. Okay, in the iterator part. In the traversing part it is, right? In the list. We can traverse in 4 ways. Legacy loop, for each loop, and then the iterator. Then if we are working with the list, then list iterator, and then streams, right? I'm audible?
Yeah.
All right. So this is the basic thing, right? So what I want to know is simple. I mean, okay, wait. All right, interview, and over here, updating collection while traversing. Cool. So we are going to do this in this manner. And now one thing for you to know. All right. And okay. All right. One more question is there. Okay. Modifying arrays dot. Okay. Arrays as list. All right. And one. So there are two ways in which things will fail in this code. First thing is, I mean, I want you people to answer this question. List integer. All right. So let's call it list. Everyone understand this thing, right? What we are doing? Then arrays as list 1 2 3 and 4. Cool. I'm audible?
Yeah.
If I print the list, it will print 1 2 3 4. I mean, it's the two string of a list class, arrays class. So now what I want, choose any. Okay, which one will use? For each loop we can use, right? Integer value and okay, list this out. We have already done it, right? Value and then this. Cool. We have already done this, right? If we run this now, 1 2 3 4. Okay, in the next line it will be printed. Okay, wait, let me remove the len and then run it again, and then 1 2 3 4, right? This is the output that we have. All right, cool. What if I wanted to add when I am at the 2? All right, and let's say I have 5 over here. All right, 1 2 3 5. If I run, that value will be 1 2 3 4 5, right? What if as soon, okay, 1 second. All right, so what if, Kishore, we are getting some background noise from your end. All right, cool. Okay.
Okay. Shall I block the? I'll block the microphone. Yeah.
Yes, you can mute it. Okay, so all right, so now if I want, so the list has values 1 2 3 4 and 5, right? Visible over here. So if I want to add the value 4, right, while traversing, so what I want to do is, if I do if value equals to 3, all right, or 2. Cool. So this list dot add 4. Great. Okay, everyone are aware, right? If I do list dot add, the value will be added to the list. Am I audible?
Yeah.
All right, cool. So now the thing is, if I run this code, what will happen? What will be the output?
It will be 1, 2, 4, 3, and 5.
Okay, cool. Okay, cool. All right. The answer will be an exception, unsupported exception, right? Now the thing is, this interview question is different from this interview question, and I want you to know that both will throw an exception, but the thing is, the exception you need to understand why these two having different exceptions. One thing is this as list that I'm using, it returns a list, right? But it returns. Okay, wait. Yeah. Okay. As list, why? I mean, I think it's no, 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 no. For which method they are saying for this? I mean, as list is non-modifiable collection. Unmodifiable list, it returns. So if this list will be static. It does not support modifications. But why it's saying that it returns a fixed size back to a specific array changes to this made visible? All right, okay. This thing, okay. The return list implements the optional collection method, except those would change the size of the return list. Those methods leave the list unchanged and throw unsupported operation. Visible? Am I audible?
Yeah.
The thing is, the list that we are creating is cannot we cannot change it, right? It's fixed list that I'm creating. Unmodified list it is. If I use array dot as list. All right. Am I audible?
Yeah. Yeah. Okay.
So this thing, unmodified, unsupported operation exception it is. It's saying that add is not supported, right? Am I audible?
Yes.
Now the thing is, now you can say that all right, if I'll do list dot add 1 2 3, then if I run this again, same thing, right? It does not mean whether while I'm traversing or not. It does not concern. It just simply says that okay, if you are using as list, you will get unmodifiable list. You cannot change it. It's a final list. You cannot change any data out of it. One thing, right? So this exception is different. Then why I have put this thing in the for each loop? Because this is introduced just to make sure you get confused. All right. So if you're using array.as list, your list will be unmodifiable, right? Your list will be unmodifiable list. So now the thing is, we'll go ahead and see the another question over here. Now we know that okay, if I use the arrays.as list, then I won't be able to modify it, right? Am I audible?
Yeah.
So let's just simply go over here and try to mimic this thing. And instead of using array.as list, what I'm going to do, I will use normal array list. All right. And add normal array list. And now I have to work now. I need to put these values 1 2 3 4 over here, 1 2 over here 3, and over here 4. All right. So the thing is, let's not write this code. Let me just remove this for a while and print the list, right? It will print the same output, right? Array dot as list, but this list will be modifiable. Okay, has it run? Okay, it run already, right? And let me show you that it's allowed to add the values over here afterward as well, right? I'm adding 5, so no errors, right? And if I print again the list after adding 5, the value will be increased to 1 2 3 4 5, right? So with the normal list, it's allowed to update the value or add the value after the list has been created. So now we know this thing, right? That these operations are allowed. So what I want to do is, now I'll start again the for each loop. So list I'll provide over here. Clear till now? Am I audible?
Yes, yes.
And let's just comment out this line for a while, and do value n plus comma and this thing, right? And run it again so that we can see. Okay, I need to remove the ln as well. All right, just run it now. 1 2 3 4 over here. Cool. So now the thing is, we know that okay, 1 2 3 4 will be printed, right? And let's make it 5. Now I want to make sure that 4 5 I want to add 4 over here, right? Instead of 5 I will add 4. See, to add the 4, this operation is acceptable, right? We already know it. We run it also, right? Now the thing is, I will say that if value equal 3, then add 4. All right, visible?
Yeah.
Now if I run this, what will be the output? Earlier there was an exception because the list was unmodifiable. Now what will be the case?
It will be added. So 1, 2, 3, 4, 5.
Again, there will be an exception. Now the exception name will be concurrent modification exception in this thing. Visible?
Yeah.
So both times, I mean, why the earlier question was important, because people read about this, because concurrent modification exception is a very common interview question people ask. Then the fail fast iterators and fail safe iterators also. There is the follow-up question is fail fast and fail safe iterators. But we need to know that both will provide exception, but that's true, but both exceptions are different, right? This will provide unmodifiable list exception, right? Or something like that. Unmodified list, okay. Unsupported operation exception, all right. This will provide unsupported operation exception because that list does not support adding any new value or removing as well, right? But with this is concurrent modification. And what is concurrent modification? Concurrent means something is happening parallelly, right? I'm audible?
Yeah.
So it's saying that concurrent modification is so something. I mean, we are only a single people. We now we know about the thread, so we know that there is a single thread working over here. No multi-threading is doing. So who is concurrently updating, right? So the concurrent over here is not for the multi-threading, even though it can be used for the threads, because in the case there will be a case where multiple threads are using the same collection, will become the resource, right? Like the washroom we have used or the voting machines we have used in the multi-threading classes. So concurrent over here means that we are traversing the collection also, right? We are traversing the collections, and while traversing it, what we are doing is, I'm audible? Hello?
Yeah.
While we are traversing the list, we are doing one operation of traversing. And at that particular time, we are adding the value also, right? We are concurrently trying to do two operations on the single resource parallelly. Am I audible? That's the thing, concurrent modification exception. Now, there are two questions that arise out of this, and now please bear in mind this is important thing. First thing, how the list know, how the collection know that we are updating the collection, right? First thing. Next thing is, if we are updating the collection, why they are throwing the error, right? Why to throw the exceptions when we are traversing it, right? These two questions must come, right? Why they don't allow us to add the value while we are traversing? One thing is that same resource, there might be a chance that different people are reading the value, are modifying the data, right? For example, if I'm trying to get the student with the maximum number of marks in the class, all right. So at present there might be 30 students. While I take why I started the collection, there might be a chance there are 30 students, right? But after, while I'm processing the data, there might be a chance that 31st student also gets enrolled. Now, but what will happen if the 31st student was inserted at the very first position over here, and I have already covered the index 0, and I'm at the fifth position, with the value fifth position, that would be the third index. So I'm not, I mean, my this collection will not going to move backward, right? Because I'm using for each loop, it will only move forward. So that,
Yes.
so the outcome of my data will be wrong, right? So it's a race condition while someone else come and updated it. So instead of someone else, we ourselves also cannot update the value. That's the condition with the collections. And right now, then there is a question that we usually people say. Now the first thing, let's see how they know, how they know that something has happened. I'm audible.
Yeah.
So the answer is in the array list or any collection, you will see the mod count visible over here. Okay, the very first thing, iterator is also a design pattern. Cool. And over here, it's the mod count visible, this mod count. What happens internally now that this mod count, anytime, I mean, it depends. Whenever I try to get this thing, whenever I try and update the value of this collection, like I'm adding a value on the collection, right? Okay, let me show you what happens when we add the thing. All right, see, I'm adding a value on it, right? I'm audible.
Yeah.
So let's go inside this thing and see when I do the add, what happens? It increase the mod count. All right. So what's the value of the mod count? 0. So I added the value for the first time. Mod count will become 1, right?
Yeah.
And then if I add again, mod count will become 2. Then mod count will become 3. Mod count will become 4. So whenever we start traversing the collection, what happens? That it takes the mod count that okay, I am starting traversing this array list when it has been updated for the 1 2 3 4 times, right? So every time it goes to fetch the new value, it checks whether the mod count has updated or not. And as soon as I updated this value, the mod count will become 5, right? I'm audible.
Yeah.
The mod count will become 5 over here, and it wanted mod count to be 4. And as soon as it'll see there is a difference between mod count, it will throw an exception. But when the exception will be thrown, that's also a case. I'm audible. Let's say over here, if I say, if you think that okay, when I'm adding the data, then then the error will be thrown. There is another thing also, and another thing will be okay, updated. Okay, traversed. Let's say traversed value. Okay. And what should I print every time? Okay, next value should be and let's say value plus 1. All right. So if I run this, now you will see value, next value 3. I was at 3 and next value should be 4, right? So if I have written 3, then this thing happened, right? And the next value should be 4. So when I'm adding the value, then there is no exception. But again, when I'm trying to take the next value from the collection, then the exception happens. All right. I'm audible.
Yeah.
So this is important thing, and I've been using this mod count in my, I mean, this is a design pattern. It's called iterator design pattern, where we check this thing and then do these things. So iterator is a design pattern. If you'll see, it's a part of behavioral design pattern. So we use it on our daily life as well when we wanted to write something like in this manner, where we don't want to allow concurrent things while we are reading or updating data. All right, and okay, okay. So 1 2 3 4. All right, cool. So this is clear, right? How it checks internally, how it knows that okay, the modification has been done. I'm audible.
Yes.
So now the thing is, now thing comes that okay, what is fail fast and fail safe iterator? All right. So okay, let's do this thing with iterators as well. All right, and then only we'll be able to do this. So traversing, in the traversing. All right. In this also. Over here, let's put iterator as well in interview questions for iterator. In the package, my bad, new package iterator, and we have already covered this, so we'll just have interview questions. All right, so in Java, fail safe and fail fast. All right, let's reverse this because we have already seen fail fast, fail fast, fail safe, iterator runner, iterator runner. Cool. All right, so now the thing is, what is fail safe and fail fast iterator, right? So fail fast iterator, right now what we have seen is fail fast or fail safe. Okay, let's do one more thing. Okay, we have seen by adding the value there was some issue, right? While adding the value there was some issue, right? So let's do one thing, removing data while traversing runner. All right, we what we have done in the last part, we try to add the data, right? We try to add the data over here, but right now I don't want to add, I want to remove. I want to remove in the index 0 1 2 3. I want to remove the value from the third index. All right, am I visible? Am I audible? Sorry.
Yeah.
So what will be the output now?
Error again. Mm,
All right, okay,
Exception.
we need to know that what happens when we do the remove. All right, so in the remove, are we able to see that some value is updating over here when I'm updating the value? Mod count plus plus visible. So if mod count has changed, so everything will remain same, the mod count will become 5, right? Over here again, when it comes, it will see the difference, and then there will be concurrent modification exception. But why there is no concurrent modification exception? Because it was last value and it does not move. One can think because we remove the last value, right? So if I try to remove the value when it's 1, when it's 2, and I want to remove at the index 0 1 2. Okay, let's do one thing. When the index is 1, we'll print 1, and when we are printing 2, when the value is 2, we can remove the 5, right? So index third. If we run this now there is an error, right? So this is an edge case. It will only check for the concurrent modification exception if they want to, if it's going to go and try to fetch next value, then only it will throw the exception. But if it's not going to take any more data from the collection, it was the last collection that we were traversing, then there will be no error, right? Because what we have seen in the last example, that when we add or when we remove, then there is no exception that occurs, right? When we reach at the line this, then only see the exception arise at line number 16 visible. It's also saying the same thing. Am I audible? Hello, am I audible?
Yeah. Yeah.
All right. So you can also see over here that the line number 16, the exception arise when we are at the line number 16, not when we are doing operation, or not when we are completing the value, right? So when we don't even want to the next value, then there will no comparison that will happen. All right, so this is again an edge case. Very rare people ask the edge case, and it's completely all right if people are unable to answer the edge case in the first go. But if you are 5 years experience, then at the second go, right, once you are answered the wrong way, then if someone asks you, okay, why it happened, why there was no exception there, then after 1 minute max or 2 minute max, at least 3 4 minutes, then you must be able to answer, right? That how it internally works. In 4 5 minutes is just given so that you can think, if you haven't worked with the Java, or read about this thing, then for just to recall you will get 2 to 3 minutes. All right, clear till now? Hello.
Yeah, yeah.
All right, so let's move to the another part where we are going to do the same thing but with the iterators. Okay, in the traversing only we have to do this thing. Okay, all right. So in the traversing, iterators, arrest, iterator, interview question. All right, so over here the same thing we will try to take, right? First this example okay, my bad. This example we'll take, and we know that if I run this thing, there will be an exception, right? So let's just copy paste the code over here and take it to our class of iterator, fail safe iterator, fail fast and fail safe. All right, so okay, let's first we need to know what is fail fast and fail safe. Okay, so now instead of doing the for loop, right, what I can replace this thing with is iterator. And how we get the iterator, integer iterator, we have already seen it in the last session. And I want itr and list. The data structures provide you the iterator, right? Because the design pattern, it has been provided by the data structures. So over here I will write while itr dot has next. For those who haven't taken the last session, everything will be the same. Like for example, in the manner that we were traversing earlier, it will replicate the same thing. We have 1 2 3 4 in our list. Okay, let's make it 4 now. We have 1 2 3 4 in our list. 1 2 3 and 4. Our I will be at the -1 for now, and will move with the right side because iterator, okay, not less iterator, give me normal iterator. All right, so the iterator, normal iterator, can move only towards the right hand side, so it's exactly same as of the for each loop. Now what will happen, if I'll say has next, it will check whether the next index of it, that will be 0 index, has the value or not. It has the value, so this thing will return true. Hex next return the true boolean true, so it will return the true. Then I need value, right? Over here we were using value, so itr dot next. So iterator next, what will happen, I have checked that next value exists, right? So if next value exists, please give me the next value. So next will provide me the one value, but for that it will move at the 0th index, and then it will provide me the one value. And then the same operation I will operate with the one value, and then what will happen, I will move next again. Then if I'll see next, then it will check, okay, I'm at the index 0, let's check whether we have the value at 1 index or not, and we have the 1 index, so it will return me true. So again, when I ask for the next value, it will increment the index, and then the second value it will provide over here, so we'll get the 2. All right, I'm audible?
Yeah.
Clear till now? So what will happen now if I try to remove this thing, if I try to do with the iterator, what will happen now? What should happen now? Okay, if I try to run with this, it will fail. Concurrent modification exception is still, right? But now we know that the iterator also has a method remove, right? I'm audible?
Yeah.
So if I'll ask the iterator to remove the value, then what will happen? First thing is iterator does not take any value. It will, you will just say remove. So what will happen, in whichever index it is currently sitting, right now it's sitting at the second index, right, value 2, so it is on the first index, right? So it will remove that value. I'm audible? And once it's completes, and okay, it depends whether it will be able to do that or not, then modified list. If it will be able to complete, then we will see this. If it's not, then we won't be able to see this, right? So list, okay, my bad. All right, visible? This line will be printed only and only if there will be no exception over here, right? What will happen if I try to run the code now? I'm not removing the data directly from the collection, I'm removing it from the iterator. What will happen now? Okay, let's run the code directly. No errors, right? And the value has been removed as well. Second value has been removed because if value equals to 2, remove that value. So if we use the iterators, then we don't face any. If we use the iterators methods, then we don't face any. Is it the last value that we removed? No, because it was not the edge case, right? It was the second value. After that we have traversed, we have get 2 more values, right? I'm audible? Hello? So this is not the edge case. If you want to remove anything from the list while traversing the list, then we should go for iterator.remove. If I want to remove, if you want to add, then we'll go for the list.add, right? Because list iterator provides a functionality to add as well. But bear in mind that this is only and only for the case where you yourself are traversing and you yourself are updating the value. If someone else has updated the value using iterator.remove or the list iterator.add, then it does not matter, right? Because if you yourself are updating, then it's cool. But if someone else is updating the value when you are traversing, then there will be an exception. All right. And then okay, so we have array list. So in the array list we have iterator, and this is the iterator class, and iterator.remove we want. Okay, we don't have this implementation. It just runs about remove. It's over here. So we don't have the compiled version of this thing. Otherwise I would have shown that how it internally works. And simply it does not throw an exception because it does not impact it. It keeps the mod count same, so it does not impact the traversing. All right, am I clear till now?
Yeah.
So one thing is, so now the question is, this thing, if we can use iterator and if we use the iterator methods, then it's completely fine, there will be no error, right? But why are these things, what are fail safe and fail fast? Okay, have you ever heard of this thing, fail safe and fail fast?
No.
All right, no worries. So the thing is, whenever we are doing something, fail fast and fail safe iterators, these are something as soon as we have updated the value over here, right? Without anything, I mean, okay, if I use normally, if I'm using iterator methods, then it's completely cool. But if I'm not using iterator methods, then we know that there will be an exception, right? Concurrent modification. I'm audible? So what
Yeah.
happens, there are some collections: array list, linked list, stack, vector, hash set, hash map, linked hash set, linked hash map. These all are fail fast iterators. If you update the value while traversing it without iterator, then you are going to get concurrent modification exception directly, right? There is no other alternative to this. If someone else has updated it, then also you will get the exception directly. Cool. So we have to be very careful if we are sharing this resource, this collection. If we are sharing it with multiple methods, then we need to be very critical about this thing, because if two threads are updating on the same thing and both are traversing, and while traversing both, if we use the iterator, then for that particular collection, that particular iterator, and while traversing, the mod count will be something else, but for another thread the mod count will be something else, so concurrent modification exception will arise. So while sharing the exception, we have to keep this in mind. So this is resources again. So now what happened, these are called fail fast exception iterators. As soon as you update it, it will fail at that particular time. And what is fail safe? Okay, so it's an example of fail fast, but we haven't made it fail fast, so it's okay, it's not, it's an example. Need to change this thing. Okay, using iterator remove method runner. All right, So this is, and this is not an interview question, we can put it in the basic part. Okay, this is an interview question, but okay, cool, let's keep it here only. So now let's see fail safe collection runner. All right, so anyone having any idea about any fail safe iterators or collection? I'm audible? All right, no worries. So see, let's write something first and then we'll update the code. So let me know something, anything. I mean, let me know if I will be able to do this thing or not, and what will be the output now. So if I'll do this thing, list equals to new array list. Okay, whether I'll choose the linked list, array list, it will be completely same for, because we are working with the list right now. It will be, the difference will be exactly the same, which is for the list and this thing. So instead of putting this thing I equals to 0, I less than 5 and I plus plus, what I'm doing is list dot add and I plus 1. Yes, so I plus 1. All right, or let's do one thing, let's start with 1 and put this thing over here 1. Okay, not bad. I, so now my collection will have values from 1 to 5, right? 1 to 5 visible?
Yeah.
All right, let's move it now. Now I want to add some value. All right, let's use for each loop, integer value and list, and then let's do list. Let's do an add, or let's do an remove. Let's do a remove, right? First remove, then we'll do something, and then I want to remove value from index 1, right? And I want to print the values as well. Print the value, and if I equals oh sorry my bad, if value equals to 3, then remove the position from the first index, then remove the 1. All right, this is a thing. And let me write the last thing. Okay, so this is out updated list, right? If there is no error, then I will reach in this thing at the updated list, right? And updated list will not have 1 over here, right? What will happen if I run this code now? I'm audible? Concurrent modification exception. I'm audible?
Yeah.
So nothing we have changed, nothing, right? So concurrent modification exception will be here, because over here the mod count was 1 2 3 4 5. Mod count was 5, right? When we printed, mod count was 5 over here. Mod count 5. Mod count was 5 over here when we started the list. So the mod count was 5, and here mod count become 6. So obviously after 3, when I'm again try to go and fetch 4, there will be an exception. After 3, when we'll try to go and fetch 4, there is an exception, right? But the same thing, this is called fail fast iterator, right? As soon as someone has updated, then there will be an exception. But what if instead of this, if we use some of the collection which is not fail fast, then what will happen? Copy on write array list. All right, so this is a implementation of fail fast. I mean, let's see. Okay, fail safe. If we run this now, what will happen? Nothing happened, right? We printed 1 2 3 4 5, but eventually this thing happened, right? I'm audible?
Yeah.
So this is fail safe iterator. So whenever we are iterating on the fail safe collection, then there will be no exception if we are modification or doing the modification while traversing also. All right, So over here, if I'm updating the value, it's not checking the mod count, and these things is not happening over here. The reason is it's doing it, but it's the updating things while we are updating, it's updating on a different array. It's not directly updating here with the same collections. So the thing is, if I want, and how many classes are there, like this copy on write array list, how many important classes are there? Am I audible?
You mean like list, set, and map?
Yes, great. So copy on write array list. So just give me 1 second. I just get a message from office. Okay, this thing. Okay, all right. 42 after half an hour. All right. Okay, yes. You mentioned something.
Yeah, list, set, and map.
Yes. These are the three most important collection interfaces, right? Great. So this is for copy on write array list, right? I'm audible. So this is for the list, right? So there should be
Yeah.
something for the set and map also, right? So for the set, for the map, we have the concurrent hash map visible. Concurrent hash map. I'm audible. All right.
Yeah.
So similarly, copy on write array set visible. This class is for set. This class that we have used is for list, and concurrent hash set is for map, right? Because these are the three important main interfaces of the collection. So we have all the fail-safe iterators for these three classes: copy on write array list, copy on write hash set, and concurrent hash map. All right. So set, map, and list all are covered. Okay, let's move on. See, the difference we need to know. First thing, how the iterator knows, or how while we are iterating to while we are iterating any collection, how does it know that modification has happened? It has the mod count. Each implementation class of a collection has a mod count. Whenever we update the collection, we update any remove or any operation that we do on our collection, that its mod count gets increased. So when we start the traversal, we take the mod count and save it with us. And if we find any discrepancy in the mod count of what when we started and what has become when we went to fetch next element, then at a particular time we throw the concurrent modification exception. That happens in the fail fast iterators, but there are fail safe iterators as well. And why do we want the iterator to fail fast? In those cases where the data integrity might be compromised, like for example that I mentioned, that is someone insert the data in the very first place, then there will be an issue, right? So at that particular time the data integrity will get impacted, right? Because we have removed a student, right, at this particular time. So one student, we are down with one student after the list is completed. So it does not allow it it does not allow multiple or ourselves also while traversing the collection to update or perform any modification on the collection. So it throws the concurrent modification exception. It says whether you traverse or you update, don't do parallelly, right? Either traverse or update. So parallel things is not allowed in fail fast iterators or collections. Collection provide the iterators, right? Okay, there is one confusion with a lot of people, that fail fast is iterator. In question you will get the iterator, right? But who provides that iterator? In the array list. In the array list, collection has the iterator because iterator is a design pattern. So you will get this function is providing iterator, and itr, if you will go, this class is side in the array list class, right? Visible? This class private
Yeah.
side class, this its implementation. So we get it from the iterator, and see the expected mod count visible over here. It's taking the mod count. Expected mod count will be the current mod count that it has. If we update it, then we'll get the error. You can see this thing over here as well. When we go and try to get the next value, it check for the concurrent modification. And how it's doing it, expected mod count, it's trying to match with the mod count, current mod count with the expected mod count. What's the expected mod count? Which it has taken, okay, which it has taken when we have created the object, when we ask for the object of this iterator object, right? So that's how check modification exception is thrown. All right, internally this is how it works. I'm audible?
Yeah.
All right. So okay, so this was our iterator. All right, iterators. So let's, now we know, we have seen how to traverse this data, right, this collections. So now the next thing would be how we can sort these collections. So package list, oh my bad, I need to update it. So it will be list, and then okay, what's happening now? All right, so there will be set and list set and map. All right, so I want to sort a list, a single example. Okay, yes, it's going to take some time. So I want to sort it, so I need to sort it using compatible and comparable. Okay. So let's create two more packages. One comparable, another package will be comparator. All right, so there are two ways in which we can run it. So comparable basic, and over here we can have sorting comparable runner. All right, so now again, this is again very important thing, comparable versus comparator. Anyone aware of this thing, this question? When to use comparable, what is comparable in comparator? Okay, everyone is learning for the first time. Okay, my bad, sorry. So okay, so there are two ways in which we can sort the collections, right? The one way is by comparator. This is also class, it's an interface. So if we come over here again and see, you will see comparator and comparable visible in this interface. Comparable and comparator, right? Iterator and list iterator we have seen. Enumeration, nobody uses in current day and age. So now we are at comparable and comparator, right? So let's go. Both are used for sorting, like iterator and list iterator are used for traversing. So comparator and comparable are both are used for sorting the collection. So now the question arises how we can use comparator and comparable, and which one is important. So both of the things we are going to cover now. So the first thing is comparable. All right, so with comparable we can see that it is a interface, right? Visible? Am I audible?
Yeah.
Okay, so let's create a list first of integer. All right, and the list equals to new array list, and then let's simply go and list dot, oh my bad, list dot add, and then okay, let's do in some different order. Let's put value 3, 1 and 4 and 2, 4 and 2. All right, so if I'll do this thing and print the list, then the value will be in the same order, right? Because list maintains a sequence, so 3 1 4 2, right? So you must have seen one thing, arrays dot sort. Have you seen this thing? This method? I'm audible? Alright, cool.
Yeah.
Yes, if you are doing the coding thing in the lead code and some other website, you must have used this thing or seen this somewhere, right? But this arrays dot sort is for primitive data types, right? You will see all its overloaded methods are for primitive data type array, right? It's not for collections, right? Then what we can do for the collection? So in collection is an interface, all right? Collection, okay, my bad. Collection is an interface collection. Collections is a utility class, all right? So if I'll go to the collections and say that, okay, collections, are you able to sort things up? So collection dot sort and then list, all right? So I have provided this list for the collection dot sort, and if I'll print the list now, what will happen then? After sorting, okay, before sorting and after sorting, okay, so before sorting and over here we'll do after sorting. Visible?
Yeah.
The output will remain same, it's just for seeing, all right? So after sorting it's 1 2 3 4, right? So is it this much easy that just do the collection dot sort, right? Is it this much easy to sort things up? So the thing, okay, so let's change the things. Instead of using this list of integer, what if I'll change the code and instead of this thing I'll use the character, and okay, char list, and update the char list to this, and char list and character list, and update this thing to characters like D and then A and then C and then B. Alright, if we run this now, you will see before sorting DSCP, after sorting ABCD. Visible? So again, is this much easy to sort a thing? The answer is yes, but for the classes which implements the comparable. Visible? This character implements comparable. Visible?
Yeah.
So now the thing is, if I try to do the same thing, and even the collection dot sort, if you'll see that it wants, okay, it wants something, wait, my bad, collection dot sort, and over here we become the list. But the thing is, this list, visible, this object must be the child class of comparable, then only we can use the collection dot sort, right? It must be the child class of comparable. So this, all the wrapper classes are child classes of comparable, because all wrapper classes are implementing comparable. Visible? I'm audible?
Yeah.
So that's why if you have the wrapper classes, then you don't need to do anything for sorting. But what if you have a, okay, you have a employee, let's add employee object, right? And your employee has two things, at the rate getter, then at the rate setter, at the rate builder. All right, cool. So now if your employee has a name, private string name, and your employee has private integer employee ID, all right? So these two data your employee have, right? So now we know if we want to use it with the collection dot sort, all right, employee sorting runner, my bad, employee sorting runner. All right, so psvm, if I create two employees, employee dot employee builder, oh my bad, employee dot builder dot employee id 1 dot name, let's say Ram, and okay, my bad, build. All right, so it will be object of employee Ram. All right, in similar manner, if I'll take Sham, so I'll just update the name to Sham. Okay, but the example should be in a manner where R comes before. Okay, QRS. Okay, if I sort with the Ram name, then Ram will be at the top. QRS. Okay, so I will change the things up. Sequencing I'll change. Sham will be the employee number 1. Ram will be the employee number 2. And that's it. Okay. Sham is 1, Ram is 2. Alright, cool. So this, and then I'll have a collection list of employee now. Earlier we were taking a string integer, now we'll have the list of employee and we'll call them employees equals to new array list. And it's in the same manner we will add employees to Ram, and then the same thing we'll do with the Sham. Cool. So let's add a toString also at the employee so that we will know that what's happening with the list. So let's print the list now. So employees. All right, so if I run the code now, we will see the employee, because in the same manner Ram and Sham, because I've added the Ram and Sham in the same manner, right? But what if I want to sort Ram and Sham, right? So if I try to use collections dot sort and then put the employees, there will be an error. The error will say that the employee is not a child class of C. That collection T, that T is an employee for us, which is not a child class of comparator or comparable. All right. So it must be a child class of any one of these. Either I should provide the comparator or it should be a child class of comparable. All right. So there is no comparable, no comparator. So now what can I do? I should make my employee class a child class of comparable, my bad. So right now implements comparable. So comparable takes comparator is generic, because your class can have multiple data to sort, right? So we need to mention for the integers, integer is a wrapper class, it has only one value, right? Int. Long will have only one value, long. Character wrapper class will have only single value character, so it will compare based on those things. But if we have some complex object like the employee, then it can have multiple fields out of which we can choose that which we need to use for sorting, right? I can sort with the name, I can sort with the employee ID. If I sort with the name, then Ram will be first and Sham will be second, right? But if I sort with the employee ID, then Sham will be first and Ram will be second, right? Clear till now? Hello.
Yeah.
All right, cool. So let's go to the employee and let's sort with the employee ID. So I'll say that I'll choose integer to compare. Now the comparable has a method compare to. Is it a function interface? Is it a function interface? Not visible, right? But it has function interface was not written, but how many method does it has? Abstract method, a single one, right? Only this implementation, a single method is there, right? So we can consider it, say it's a function interface, right? But it is there from the 1.2. Oh, comparator, okay, but it is from the 1.2 legacy. It's a part of legacy. So let's move backward, and now let's use the comparator. So we need to implement the methods, right? So compare to method we need to implement, and now this compare to method we already seen this method in the string as well, right? We have seen this in the string or not? Hello, I'm audible?
Yeah.
All right. So now the thing is over here now. Okay, so if we haven't seen it in the string, then we have to see it over here. That what happens, how it will consider that whether it needs to sort or not, right? It will have one object, right? Employee object it will have. Let's suppose that this employee will be Ram, all right? And then it wants an integer again over here, right? So another integer will come over here, right? Am I audible? Hello, am I audible?
Yeah.
So I need to now based on the data, that I'm going to return from here, and I'm going to return an integer, right? So how can I return now the value that will be in the integer, and how will it sort, right? Let's go inside it again. So it has integer only, right? Regardless of your type, it will have only integer to return, right? Whether you are using character, then only you need to return the integer. Whether you are using the student object, then also you need to return integer only, right? And based on your integer, it will decide whether it needs to replace the value in the list or not. How the sorting happens? We replace the values, right, in this list. Okay, sorting can happen in place, right? In Are you aware of sorting? In what is in place sorting?
No.
Okay, okay. All right. So the thing is, okay. All right. Just give me 1 second. I'm having a call right now. Just give me. Okay. So it's going to compare two objects, right? Current object will be this. Another object will be the object that we are taking over here. So now we want to compare things, right? So we can directly take the integer as well that we are comparing, but the thing is we should take the same object as well every time. So over here also it will gets updated, and we can say it employee 2. All right. So it's going to compare the employee with another employee, right? This code will be more readable. So now I want to make sure that this is also an employee, right? This will be an employee that will be get compared to another employee. So this employee, or I can directly say employee ID, but from instance area I can use this as well. And then because it's primitive, I can just directly make sure I can just get the value which is greater. So now the thing is how it knows that whether it needs to sort or not, right? So the logic is, if we find a value, right, if it finds negative value, all right, that means p1 is less than p2. All right, think about it as an integer, that if I do p1 minus p2 and the answer is negative, then p1 is greater, my bad, then the p1 will be greater, right? I'm audible?
Yeah.
So if we compare two objects, if it thinks that okay, negative has come, so what will be the first object, right? P1 and P2. How we compare that, what is P1 and what is P2? It depends on which object it's working on, right? So the current object it is, right? For the current object it is, let's suppose that this is Ram. The next employee will be Sham, right? So if I return minus anything in the negative, if I return 0, then means both are equal, right? But if I return the negative, then it says that O1, object 1 should be the first, or the Ram should be the first if the current object is Ram. All right. So for negative, change will happen or not?
Yes.
And negative means, see, it's relative item. If I return negative and we are working with the employee, so it says that emp1, employee 1, the current object, employee 1 will be the current object, right? It can be Sham, and employee 2 we have taken over here. So employee 1 should come before, and then after this thing we'll try to mimic it with using the primitive types. So employee 1 should come before employee 2. All right. 0, what should happen? Is equal, right? Nothing should happen. Whatever sequence is there, it will be maintained. Then positive 1, I mean, it's not like we need to return 1, we can return any value, right? Because it's integer, right? We can add any value it's usually positive. It's not 1, it's positive and negative. It's negative and it's positive. And if this thing is positive, if we return this thing as positive, then that means employee 1 should come after. See, if we have written before, then it will be only after, right? After employee 2. So based on this thing, we need to make sure in which order we want the data to be. For example, it's obviously simple. Written what we are going to do. We'll do employee ID, all right, minus emp2 dot. Hey. Okay, getter is not working. Okay, getter is there. Employee object is this. Okay, my bad. Employee 2 dot get ID. All right. So now it depends how it's going to take the data. It's list, so it will start from Ram, right? I have taken Ram for the first object, right? It will take the object of Ram, compare it with Shyam, right? So Ram employee ID is 2. Visible? And the another object will be
Yeah.
Ram. So what will happen? Ram minus Ram ID minus Shyam ID. Right now, if we run the code, so it will be in sequence, right? Shyam will come first and Ram will come second. Okay, no. I have added code in different way, right? I have added in this. So Ram will be come first. Okay, so let me write also this thing. Before sorting and after sorting. Before sorting, this was the thing. And after sorting, employees, oh, it's happened to this. And see, this line is not throwing any error right now, right? Because now our employee is child class of comparable, right? So if I run the code now, before sorting, Ram was first and Sham was second, right? In the same order that we have inserted the employees, because list preserve the insertion order. But after collection.sort, Sham becomes first employee and the Ram becomes second, right? Because we sorted according to the employee ID, right? Am I audible?
Yeah.
And what if I want to sort in reverse order? This is in the ascending order, right? If I want to, this is in ascending order of employee ID, right? What if I want descending order of employee ID? So nothing else, I'll just remove this thing, employee ID minus this. Now if I just go here and run it, now the data is same, but let's add one more employee now, and then reverse the things. Ram Sham, and let's make the employee ID of Ram 2, and let's add something else, Ram Sham and Lakshman. Let's say Lakshman and Lakshman. All right, and Lakshman employee ID is 3. All right, and we'll add data in different manner. We will add Lakshman after Ram. So Lakshman, okay, cool. So now the Ram has 2, Lakshman is 3. So 2, 3, 1 will be the first value, and after sorting it should be 3, 2, 1. 2, 3, 1 insertion order is preserved. After sorting, 3, 2, 1 descending order. Clear?
Yeah.
Okay, so if you have done a lot of sorting questions, so it will be, you will find a little time to get through it. But if you'll play, just remember these lines, that okay, whatever your data will return, it will compare 2 objects and then try to work around with it based on these conditions, right? And now the thing is, but now if I want to compare this thing, instead of employee name, I want to compare it with employee ID. Sorry, we are comparing it with the employee ID, right? I want to compare it or sort the data with the employee name. Now how can I do it? I'm audible?
Yeah.
The answer is, this
Oh,
is the drawback of this thing, that we are forcing our class to implement a default sorting logic. It is good for a cases, for a primitive basic data types like the wrapper classes where there is only one value, right? So integer class will hold only integer object, so we don't have multiple data, right, in that particular class. But with the complex object like the employee, student, we have multiple data based on which we can sort the collection, right, or the object. So this is a drawback of comparable. That's why nobody uses comparable nowadays. So the next thing is, because comparable made us, if we want to use only comparable, right, so it made us to write or change the code, right, if I want to use a comparable and want to compare it with the employee name. So what I have to do over here, I need to return employee name dot, then compares to, and then employee2 dot get name, right. Compares to do the same thing, right, it returns the integer by comparing the two string. So that's what I need to do. So I need to make the changes in my code, right. So this thing is not recommended to use right now if you have your complex object. So what's the alternative? Alternative is comparator, right. So instead of this, we will use the student class, and the same thing we'll do with the students. Setter, getter, and builder, and we'll just have private string name and private int roll number. All right, but okay, private. But now the thing is, we don't have to write anything, extend our class anything. That's the beauty of comparator. But the thing is, we will do the student name comparator. Okay, my bad, the spelling is wrong. Student name comparator, roll number comparators. Let's first do roll number comparator. Roll number comparator. So this is the class, and now this class will implement comparator, and it will compare the student. And now we need to compare. Its method is compare. The other method was compare to. So what I'm going to do, this will be the student1, and this will be the student2. So I'll do the same thing. I'll do the ascending order thing, that is student1 dot roll number minus student2 dot get roll number, right. So we are sorting in ascending order. And now in the runner, student sorting runner. So what we need to do, simple, create the student, let's say student Dikshita, and student dot builder dot name and Dikshita, and let's give the roll number 4 and dot build, and then give the Kishore roll number DK. Okay, let's give him 3, but roll number does not make sense because it's based on the name, but it's completely cool, no worries. Let's say that it's employee, right, we just name it a student, and we can take, say, the Vinod, and Vinod, okay, the name should always start with this thing. Okay, so we can make it Vinod, and let's give Vinod roll number. Okay, if we sort it with the name, then D will come first, K, and then V. This thing in the ascending order. If I compare with the name in the ascending order, then this will be the case. So okay, so Vinod, let's give Vinod the roll number 2. All right, I'm audible. So now if I just add, let's create a list, student, okay, student, and in the student we'll have the student equals to new array list. So my bad, in the students, if I'll try to add Dikshita in the order I'm saving Kishore, and then Vinod. All right, so okay, my bad. So let's change the order just to make sure it's not in any sorted logic, and simply just print this thing. And before sorting, and simply sys out and the students. Cool. And similarly after sorting we'll do it later on. So if we run this code right now, okay, toString also need to implement it over here, toString. And now if we run the code again, now over here you will be able to see Kishore roll number 3 is there, then Dikshita roll number 4, and then roll number 2, right? This is in no sorting order, right? Roll number 3, 4, 2, no sorting logic. Kishore, K, D, and V, again no sorting order, right? So now how can I sort it? So simply I will do same thing, just copy paste. It will be after sorting, and all right, collection is an interface, collection is a helper class, collection dot sort. I want to sort my students, and I want to sort based on student roll number comparator. Visible? Now if I run this code right now, 2 3 4, all right, cool, great. 2 3 4, it's sorted, right, based on roll number. I'm audible?
Yeah.
But what if there was a drawback that I cannot sort the students based on the name in the comparable, because I can use only single sorting logic to a class, because I need to implement that thing to the object in which I am sorting. But comparator is a separate class completely, right? So if I want to create a student, oh shit, oh, this name is wrong, right? A student roll number, a student name, it's not student name comparator, it's a student roll number comparator. Okay, now spelling is again wrong. Student. All right, cool. So let's create another comparator. This will be over here. I will remove the roll number, student name comparator. All right, and over here obviously implement comparator, not character, comparator, obviously student. And over here I need to implement this compare method, and if I return student, yeah, my bad, student 1, my bad, 1, and student 2. So I'll do student 1 dot how, what's happening? Okay, student, okay, my bad, dot get name dot compare to student 2 dot get name, and simply return. So what I'll do now, after the sorting with roll number, all right, so after sorting with name, so what I'll do, I'll simply do collections dot sort my employee, or my not employee, students, and employ my student based on student number comparator, student name comparator. Visible? Now if I run this now, after sorting with name, Dikshita comes at first, Kishore second, and Vinod third. After comparison with the roll number, this comes first, then second, then third, fourth, right? Ascending order of roll number, ascending order of name. Visible?
Yeah.
So this is how we do the sorting. So let's end the session over here, and we'll connect at 7, and we'll take it forward from here. We'll cover the sets, and then we'll try to cover the map also today itself. All right.
Okay.
All right, let's end the session today.